Good day, everyone. In studio, we will present to you our midterm PIT on engineering data analysis. I am Hannah Danica Lagak, and my partner is Vanka Balbrona. A civil engineer is tasked with evaluating the failure probability of a building's structural components. Example given is beams, columns over the next 2 years. The failure of the structure could be caused by earthquake, material fatigue, or extreme wind loads. The engineer uses historical data to model the probability of failure using both union of probabilities or the overall failure of probability and binomial distribution and considers each factor independently. Now, let's calculate the overall failure probability and binomial probability. But first, let us know what is probability and binomial probability. A probability is a general concept that refers to the likelihood or chance of an event occurring. It applies to a wide range of situations where there are various possible outcomes. A binomial probability is a specific type of probability distribution used when an experiment or trial is repeated several times and each trial has only two possible outcomes, success or failure. These outcomes are mutually exclusive and exhaustive. Now, this is our concept for the factors that are given. If it exceeds, then it has the highest probability. For example, as you can see, in environmental conditions, if it's greater than 80, has the highest probability. For traffic load, it has 45,000, and material fatigue is 0.8.
Let's talk about the three key things that affect how strong and long-lasting structures are. First is the environmental conditions. These are the effects of nature on structures, things like heat, cold, rain, and humidity that can slowly weaken materials over time.
As we have computed the probability of failure and the binomial probability of environmental conditions, it appears that in environmental condition, the highest probability of failure occurred in 2023 August. And for the binomial probability, it has the highest binomial probability for environmental condition is 2022 November and 2023 July.
Next is we have here traffic loads. This refers to the weight or pressure a structure has to support, like the number of cars or trucks driving over a bridge or a road. The more vehicles there are, or the heavier they are, the more stress is placed on the structure.
As you can see in the graph, in traffic load, the highest probability of failure is 2022 April, and the highest probability of traffic load is in 2022 May.
And lastly, we have here is the material fatigue. This is what happens when a material gets weaker over time because of repeated use. Even if the pressure isn't much at first, excessive stress causes more cracks that can get worse and lead to failure.
As you can see in the data given, in our material fatigue, the highest probability of failure occurred at 2023 August, and the highest binomial probability occurred at 2022 August and 2022 prior to December, 2023 January, April, May, and June.
Here in the overall failure probability, in conclusion, as of April 2022 and August of 2023, shows the highest risk of failure that spike up to 1.
And here I present to you the overall binomial probability of the three factors. This is the combined binomial probability result of material fatigue, traffic load, and environmental conditions. Thank you for watching.